Hi, I'm Ryan of MidNite Solar. Today I want to explain to you DC circuit breakers. I want to take the mystery out of DC circuit breakers. I want to answer all the questions that we get asked about DC circuit breakers. One of the most common ones we get is, why can I not go down to Home Depot or my electrical supply house and buy a breaker panel and breakers off the shelf and build my own DC disconnect or build my own combiner box? The simple answer is, an AC circuit breaker is designed to extinguish the arc using the zero crossing, and the zero crossing is basically a point of no potential in the breaker. The AC current flow alternates directions, thus the alternating current, or AC. So they use that point where there is no current to extinguish the arc, and it makes it much easier to do. In a DC circuit, there is no zero crossing. It's full load all the time, one direction. So when you go to extinguish that arc, it's much harder to do, and it takes a special breaker to do that. When you use an AC breaker in place of a DC breaker, chances are, if it's called upon to open under load, it's going to fail, and fail miserably, sometimes even to the case of catching on fire. So it is very important that you use the proper DC breaker for the circuit you're installing that breaker in, and I'll explain that in a little bit. Before I go down that road, I do want to explain some of the breakers that we offer. MidNite has a line of breakers for virtually any need. We have a whole line of DC breakers as well as AC breakers as well. I'm not going to go into AC breakers here. That's a whole other topic. I will explain DC breakers. We have large frame breakers, 125 amp, 175 amp, 250 amp. We have panel mount breakers, 5 amps up to 100 amps. We have a 150 volt and we have a 300 volt version. The 300 volt version is double wide. It's 2 breakers internally ganged. We have DIN rail mount breakers. They mount right on a DIN rail. We have DIN rail breakers in 150 volt versions and 300 volt versions. We have them all the way up to 100 amps. We also have ground fault protection breakers. A ground fault protection breaker is required by code. Some electronics, like the classic charge controller for instance, have ground fault protection built in. Some charge controllers do not. If you do not have it, you do need ground fault protection according to National Electrical Code. This happens to be a 300 volt ground fault protection device. As you see, it's got a 1 amp pole and it's got a 50 amp pole. What this does is, the green wire goes to earth ground, the white wire goes to DC negative, and that is your reference between the two. It watches for potential between those two conductors. When it sees greater than a 1 amp potential, it opens, breaking the circuit, meeting National Electrical Code. It is important when using ground fault breakers that you don't have any other reference between DC negative or earth ground. If there's a bond between those two anywhere in the system, that will defeat the ground fault protection device. Common issue that pops up is something like a ham radio, for instance. Lots of times they make a reference between negative and earth ground. If you run chassis ground to your grounding system and you've got them hooked up to the battery, they make a reference, they defeat the ground fault protection device. So it's important to keep an eye on that and make sure you keep that functional. Okay, now I want to talk about DIN rail breakers and polarity. A little bit about the DIN rail breakers. I want to mention we have a 150 volt version. These would be used in a circuit where the voltage in the circuit is up to 150 volts. We have a 300 volt version. It would be used in a circuit where the voltage exceeds the 150 but is under 300 volts. We also have a 600 volt version that would be used in a circuit that exceeds the 300 volts but is under 600 volts. The 150 volt version up to 63 amps is single wide. The 80 and 100 amp version is double wide, 2 breakers in parallel. The 300 volt version is 2 breakers internally ganged in series. The 600 volt version is 4 breakers internally ganged in series. I do want to talk about the polarity. You'll notice that on this breaker there's a positive emblem there. You'll notice on the 300 volt breaker there's a positive and a negative emblem. The negative emblem causes a lot of questions. It does not seem right to have a negative emblem on a circuit breaker that's going in a positive line. So people do ask about that. And all this is showing you is line and load, if you will. The positive side is the side of the greatest potential. And what that means is that if you have this breaker between your PV panel and your charge controller, the PV panel has the greatest potential. So it goes to the positive emblem. If this is going between your charge controller and your battery, the battery has the greatest potential. It goes to the positive emblem. And the reason for the polarity on the breaker is they use a magnet internally to extinguish the arc. When the breaker opens under load and the arc starts, the magnet sucks the arc out of the gap and extinguishes that, allowing it to open safely repeatedly. All of our breakers are rated to open under full load repeatedly. They are switch rated for that. There is no concern about that. They do not need to be unloaded. You can just open them, close them under load, no questions. That has been demystifying DC circuit breakers. Until next time, I'm Ryan of MidNite Solar.